Hello everyone, welcome back to my channel. So in previous classes we studied about how to find the Avogadro numbers and some we just solved some word problems in yesterday class. So in today class we have a very unique topic which is all related to mole, which is kinda similar to mole in the word problems, however its definition and its criteria all the changes. So let's start. So that is our today's topic, molar volume. So basically, what is molar volume? The volume, the volume occupied, the volume occupied in 1 mole. The volume occupied in 1 mole at STP. What is STP? Standard, standard temperature, standard temperature and pressure. So this is basically a definition of molar volume. Okay, so the volume occupied in 1 mole at STP is called molar volume. So what is molar volume? So we have a constant value of molar volume. We will be discussing in STP. So first of all, let's understand that what this definition is saying. So basically, this volume is space. What is it? Space. Okay, and this mole is amount of particle. Amount of particle. I can make it small. Oh, amount of particle. Okay, so the space occupied in one amount of particle at standard temperature and pressure is called molar volume. So let's understand what STP conditions are. What STP is. STP conditions. STP conditions. STP condition says that the temperature value would be 273.15, and what is the temperature unit? Kelvin. Temperature Kelvin. Okay, and then it is pressure. Pressure is equal to 1 atm. 1 atm. So what is atm? atm is basically atmospheric pressure. Atmospheric pressure. Okay, and then now in the end we have the main molar volume. Molar volume. Molar volume value have basically these are the constant values. I can write it over there. These are the constant values. These won't be changing. These would be changing in a condition that we have to find a half of the mole, then these value will be changing. Otherwise it won't be changing. We will be putting that same value and we will be taking out any answer, any guesses. So molar volume is 22.4 dm cube. dm cube. Okay, so what is dm? Dm is basically a decimeter, a unit of volume. Decimeter, a unit of volume. That is what decimeter is. And now this is STP conditions. These are the constant STP conditions that we will be applying to find out some volume, some gases and all that things. Now let's first understand what like Charles' law and Boyle's law is saying. That we are not discussing their laws, we are only discussing their statements. That temperature and pressure, these both are STP conditions. I can write it over there. These both are STP conditions. STP conditions. Okay. So temperature and pressure. Temperature and pressure are used to fix the conditions so volume become predictable. So the volume become predictable. Okay. So what does it saying that we use temperature and pressure to fix the condition so that volume became predictable. Sorry, I forgot to write the volume. So the volume, so 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 the volume, it is showing any error. So the volume become predictable. Now it is correct. Okay. So the volume become predictable. What does it mean? Like these both are used to fix the condition so the volume become predictable. For suppose if these are won't be there, so volume can not be constant. Volume can be around like 30 dm or 15 dm or 15 dm decicentimeter. If these are over there, so we have a constant value of molar volume which is 22.4 dm cube. This is a very constant value. If you bring all the gases, like for suppose there is oxygen, there is nitrogen, if, like you may see over here, oxygen has a molar volume of 22.4 and nitrogen having also the same molar volume of 22.4. Why it is same? Because the molar volume is constant. Even though the gases are changed, however the molar volume isn't changed. So that is the conditions. Now I will be like showing you what is like temperature and what temperature is directly proportional and what is that. So let's start. Like whenever we are finding, must remember that temperature is directly proportional to volume. What does it saying that? If we increase the temperature, for suppose if we increase the temperature, the volume will also increase. Like if we increase the temperature, you may see that when you are boiling the milk, if we increase the temperature, the volume like expanded over here or expanded in the areas. And if we decrease the temperature, the volume is also decreased, the like it is came at its boiling point. So that is how it works. What is like that was a Boyle's law. Charles law, sorry, that was a Charles law. Charles law. I can write it in a different color so you may understand. That was a Charles law. Now we will be discussing Boyle's law. What he said that. He just said that pressure is inversely proportional to volume. Like what he is saying that, like for suppose if we increasing the pressure of something, the volume of it will extremely get decreases. Like if we decrease the pressure, the volume will expand, as you may see it in balloon. If we like give it a pressure, so the volume of it is decreases. If we like, if we decrease the pressure in volume, so the volume of balloon will increase. That is how this works. Okay, so next page, formula of molar volume. Formula of molar volume. What is the formula of molar volume? Mole. What is mole? An amount of substance that is expressed in gram. I have already taught in our previous classes. This is mole, and mole, like it is the same formula of mole. Just the change is that we will be using the given volume instead of using the given mass. That's it. Only change in formula. Sorry. Molar volume. Okay, so that is the formula. Now we solve some questions. Like there is a question: find the volume. Find the volume when 3 mole of H2O 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 is used. So that is our questions. So we'll be solving that using that formula. Okay, let's first understand what question is saying. Find out the volume. What volume? Given volume. As we don't have given volume, we have only mole. Okay, we have only the mole is given, that is 3, and molar volume. As we discussed that, what is molar volume? 22.4, and that is constant. We will be using it in every situation. And there's a tip that they are asking that H2O. While finding the mole, while using the mole formula, we used to like taking out the atomic mass and used to put in a molar mass. That isn't working in this molar volume. We will be like doing that. We will be using 22.4 instead of using taking out the atomic mass of H2O. Like now I will be telling to you what is mole given. 3 is given over here. 3 is given over here. 3 is equal to given volume. We have to find the given volume. We have to find the given volume, and that is upon what is molar volume? As I said, the 22.4. 22.4 is the molar volume. So if the 22.4 is in divide over here, so we'll be sending it upwards to make it multiply. It will be like that: 22.4 multiplied by 3 is equal to given volume. Okay, so that is how it works. Now what is 22.4 multiplied by 3? It would be around 67.2. And as I said that the unit will be used decicentimeter cube, so it will be dm cube dm cube is equal to given, sorry what I'm writing, given volume. So that is what our answer came as. You may see that we isn't find any H2O atomic mass. We just directly said that we just directly attempt the question by applying the 22.4 in the molar volume as it was constant. So I hope it's clear to you. I will be in the next video. We will be solving some word problem related to molar volume, so that you may get much more clearer. Okay, bye.